Hello everyone. In this lecture, we will discuss more basic definitions of a graph theory. So, in the previous lecture, we have seen that graph. What is the graph? And was the example of a graph. So, definition of a simple graph is graph which contains neither self-loop nor parallel edges is called simple graph. Multi-graph, adjacent edges and adjacent vertices. We have already seen these things. Degree of a vertex is the number of edges incident to that vertex is called degree of a vertex. So this was the example from where we found the degree of each vertices. Degree of v1 is 2 where degree of v1 is 2 where 2 edges are incident on v. Degree of v2 is 3 edges are incident on v2. Same for v3, v4, v5. So in this lecture we will discuss some more observation of a graph. Okay, so first observation is that the vertex of degree 0 is called isolated vertex. Means a vertex is degree 0. These vertices are called isolated vertex. Okay, means the vertex of degree 0 is called isolated vertex. The vertex of degree 1 is called pendant vertex. Means we have this is in a graph v1 v2. So these vertices v1 and v2 are called pendant vertex. Okay, next, every loop contributes 2 degree of a vertex. Means we have in a graph which have this is v1 and v2. So what is the degree of v2 is this is an edge that will contribute 1 plus, and the loop will contribute as a 2. So degree of this vertex means v2. The degree of v2 is 3. Means every loop contributes 2 degree of a vertex. Next is even vertex. So even vertex is a vertex having even degree is called an even vertex. Means these are vertices. So here we can say that v1, v2, v3, v4, every vertices of degree 2. So this vertex, every vertex is called even vertex. Degree v1 is 2. So the vertex v1 is even vertex. v2, v3, v4 are even vertex. Odd vertex, these vertices are odd vertices. Here we can say that degree of each vertices is 3. So it is called an odd vertex. So an edge next observation is an edge incident on a pendant vertex is called pendant edges. Means these vertices are pendant. So this edge is called pendant edge. Okay. Next is in a very important definition, regular graph. We will use this graph throughout the course of the graph theory. So a graph in which degree of all the vertices are same is called regular graph. Means we have in a graph, or in that graph the degree of each vertices is same, then we can say that graph is called regular graph. K regular graph, if we will fix the degree k, a graph in which degree of all the vertices is k, that graph is called k regular graph. Means we will say that each vertices of degree is 2, so we can say that graph is 2 regular. Okay, so here we have an examples. So this is an example where degree of each vertices is 2. So this is a 2 regular graph. Here degree of each vertices is 4. Sorry, it is in a loop. Okay, so degree of each vertices here is 4 because loop is contributing degree 2. So this vertex degree 4, 1, 2, 3, 4, 1, 2, 3, 4. This is not in a loop. This is in a edge, multi edges we can say. This is a loop. So degree of this vertex is 2, degree of this vertex is 2, 2, 2. So that is called a 4 regular graph. Now this is also an examples. This is in a basically called, it is in a called a Peterson graph, which is also a cubic graph. Means degree of each vertices is 3. Degree of each vertices is 3. So this is called in a cubic graph, and we can also say Peterson graph. Okay. Next is Weyl graph. Weyl graph of order n. Order n means we have an n vertices. So it is denoted by Wn, in which one vertex is of degree n minus 1. Means one vertex will be of degree n minus 1, and all the other vertex in the circumference is of degree 3. So we will say this example. Okay, W8 means we have an 8 vertices. So one vertices will be degree n minus 1, means that vertex will be degree of 7, because we are taking here 8 vertices, and all the vertex in the circumference is of degree 3, means all the vertices, these vertices are degree 3. Okay, so those vertices lies on the circumference, they have degree 3, and one vertex is which comes in the center, that is of degree n minus 1 if we have n vertices. Here we have an 8 vertices, so degree of this vertex is 7, and all the vertices which is lies on the circumference have degree 3. So this was Weyl graph. Next is a null graph, isolated graph, zero regular graph. A graph which is called zero regular graph is called a null graph. It means this graph is a null graph, or we can also say isolated graph. Means zero regular graph means there is no edge in graph, there is no edge in the graph, so we can say that graph is called null graph. Next is a trivial graph, a null graph. First of all, for defining the definition of a trivial graph, first of all we have a null graph means zero regular graph with one vertex, means only one vertex. So that graph is called in a trivial graph. Okay. So it is very important lemma. So lemma is saying that a sum of degree of all the vertices in a graph is even and is equal to the twice the number of edges in the graph. So mathematically we can say that means degree of each vertices, the sum of, means this is the sum, the degree and the sum of the sum of degrees of all the vertices is equal to the twice the number of edges in that graph. Basically where q is the number of edges in that graph, we will see by the help of an example. Okay, so let us suppose that we have this graph, this is in a graph. Okay, v1, v2, v3, v4, v5, we have 5 vertices. Okay, so degree of v1, degree of v2 equal plus degree of v3 plus degree of v4 plus degree of v5. So what is the degree of v1 is 2, because 2 edges are incident on v, 2 plus 2 plus 2 plus 2 plus 2. So total degree is the sum of all the degrees of the vertices is 10, equal to twice the number of edges. Number of edges here 1, 2, 3, 4, 5. Both are equal. Means sum of degrees of all the vertices is equal to the twice the number of edges. So here 5 is the number of edges. So here same is for q. Q is the number of edges in the graph, and d of v, summation d of v means degrees, the sum of degrees of all the vertices. So this is very very important lemma. Okay, so we will not do the proof of this lemma. Okay, in the next lecture we will more discuss about the definitions, some basic definitions of a graph theory. Okay, thanks.